Hello everybody, it is me Rajlakshmi and you're watching Computer Science Revision and Notes channel, and we have already completed certain units in computer science, that is operating systems, networks, programming language and graphics, software engineering. Today we will see artificial intelligence. Okay, so I have taken some problems, we'll try to solve them. So the first problem, a perceptron has input weights W1 equal to 3.9 and W2 equal to 1.1 with threshold value T equal to 0.3. What is the output does it give for the input x1 equal to 1.3 and x2 equal to 2.2? So this is a single perceptron. Okay, so they're given the inputs, they're given the input values and they're given the weights. Okay, so what is the condition here? Here for a single perceptron, the sum of the weighted inputs should be less than the greater than the threshold value. Okay, so what is the condition? So first we need to know the condition. So W1 x1 plus W2 x2 goes on up to Wn xn should be greater than the threshold value, that is like say theta. So if it's greater than theta means threshold value means output will be 1. If W1 x1 W2 x2 the weighted inputs will be less than or equal to theta means the output will be 0. So this is the condition for the threshold value. So here we have the inputs, we substitute the value here. Here the given W1 is 3.9, W2 is 1.1. okay, so we find out the value. So 3.9 into 1.3 plus 1.1 into 2.2. Here the value is minus 3.9. Okay, so it is minus 3.9 into 1.3 plus 1.1 into 2.2. So here the value will be is equal to minus 3.9 into 1.3. The value will be minus 5.07 and 2.2 into 1.1 will be 2.42. okay, so the value turns out to be minus 2.65. so here we find that what is the threshold value? The threshold value is given as T is 0.3. so threshold value theta is 0.3. So here you find that the weighted inputs value is minus 2.65. So it is less than the threshold value. So which condition will be satisfied? Only this condition is satisfied, that is less than or equal to the threshold value. So it is less than the threshold value. So what will be the output? The output will be 0. So this is the answer. The output will be 0. Okay, next problem. See, next problem here. A and B are fuzzy sets. So they are given fuzzy sets, and fuzzy addition is defined as, so A and B are fuzzy sets, and fuzzy addition is defined as mu of A plus B of Z is maximum of x plus y equal to Z of minimum of mu A of x and mu B of x. Then what is f of A plus B? So this is the question. Okay. So here A value is given as 0.3, 1, 0.6, 2, 1, 3, 0.7, 4 and 0.2, 5. Now B value is 0.5, 11, 1, 12 and 0.5, 13. So here we have two sets. Okay, so here we have to find out the fuzzy addition, which is defined by mu of a plus b. So what is a plus b of z? So it is maximum of x plus y equal to z of minimum of mu a of x and mu b of x. So first we have to find the minimum value of the fuzzy values here, 0.3, 0.5, and all these are fuzzy values. These others are integer values. So here they are asking first to find the minimum of mu of x and mu b of x. Here what we will do, we will find the minimum of each and every value. We have to compare and see, find the minimum of the fuzzy values. Okay, so here mu a of x, that is we are finding the minimum of mu a of x and mu b of x. Simultaneously we have to add x plus y. These are, this value is x and this value is y. So x plus y is equal to z value also we have to find out. So we have to add also as well. So first here we have to do the minimization value, then we have to do the maximization. So first when you have to do the minimization, along with the minimization we will do the addition of the integer values. Okay, here we have to means we have to add each and every term with each and every term. So here we have 1 2 3 4 5, 1 2 3, so there are totally 5 into 3, that is 15 values we have to write. We have to compare and write each and every fuzzy value minimum and add the integer values. So first we will do that one. Okay, first take first value 0.3, 0.1 and compare with 0.5, then 1, 0.5, 13. Three values you have to compare and write the three values. Okay, same. See 0.3 and 0.5, among 0.3 and 0.5, what is the minimum? 0.3 is minimum, so write 0.3. Next add these two values, 11 plus 1, that is 12. Next you compare this one and this one, 0.31 and 1 and 12. So we compare what is the minimum of the fuzzy values, that is 0.3 and 1, which is the minimum value, it's 0.3. So write 0.3 and add the integer values. So again 0.3 and 0.5, so it is 0.3 comma 14. Next value we have 0.6 and 0.5. So what is the minimum? 0.5. 0.5 and 11 plus 2, that is 13. Next 0.6 and 1, that is 0.6 and 14, 12 plus 2. Next 1 and 1 will be minimum is 1 only, so 1 and 15. So 12 plus 3 is 15. Next 1 and 0.5, minimum is 0.5. 0.5 and 13 plus 3, that is 16. So next value point so 1 and 0.5, so the minimum will be 0.5, and then 3 plus 11 is 14. So next term 1 and 1 3 and this value, so the value will be, the minimum will be 1 and the value will be 1 comma 12 plus 3, that is 15. Next to 1 and 0.5, so the minimum will be 0.5. So 0.5 and 13 plus 3, that is 16. Next value I take, that is 0.7. So 0.74 we have to compare. So 0.7, 0.5, the minimum is 0.5. 0.5 comma 11 plus 4, that is 15. 0.7 and 1 is 0.7. 0.7 and 16. 0.5 and 0.7, that is 0.5. 0.7 and 17. Then the next value 0.25. So 0.2 and 5. So it's 0.2 and 5. 0.15. So 0.2 and 0.5. So which is the smaller value, the small minimum is 0.2. So 0.2 and 5 plus 11 is 16, and 0.2 and 1, 0.2 comma 12 plus 5 is 17. Next 0.2 and 0.5, so the value is 0.2 comma 5 plus 3 is 18, so 18. So these are the 15 values. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 values. So among these we have to find the maximum. So first we have to take the minimum value. Next we have to take the maximum value. So how will take the maximum value? See here, if we have to take the maximum value, the integer value will be same. Only the fuzzy values only we have to do the comparison. That is, we have to find the maximum. But the integer values will remain same. So when we have integer value corresponding the thing only we have to compare. So here we have integer value 12. So see if there is any other 12 values. No, there are no 12 values. So write as 0.3 comma 12. Next we have 13. So for 13 we have, here we have 13, here we have 13, and then we have 213. So next if we have same value for the integer value, means the fuzzy value we have to compare and find the maximum value. So here 0.3 and here 0.5. So the value will be 0.5. Maximum is 0.5. So next we have to take the maximum. So here 0.3 and 0.5. So you take the maximum value, that is 0.5. So 0.5 comma 13. Next take 14. So 14 is here, 14 is here, 14 is here. So three values 14. So maximum of the fuzzy values, that is 0.3, 0.5 and 0.6. So the maximum value will be 0.6. 0.6 comma 14. Now 15 value, 15 here, 15 here, and 15 here. So 3 15 values as 1 and 15, 1 and 15, and 0.5 and 15. So the value will be 1 and 15. Maximum will be 1 and 15. Next 16 value, here is 16 value, here is 16 value, here is a 16 value. So 0.5, 0.7 and 0.2. So the maximum value is 0.7. So 0.7 comma 16. Next 17 value. So the 17 value is here, 17 value is here. So 0.5 and 0.2. So maximum is 0.5. So 0.5 comma 17. Next 18, we have only one value. So here it is 0.2 comma 18. So this is the answer for the problem. Find the f of a plus b. So f of a plus b is the value of f of a plus b. First we find the minimum value, then we have to find the maximum. Find the minimum value, then we have to find the maximum value. So this is the maximum of this minimum. Now third problem, two fuzzy sets a dash, as fuzzy sets a dash is equal to 0.2, 0.5 and 1, and then b dash is 0.3 and 0.9. Find the fuzzy relation, that is Cartesian product. So the Cartesian product of a cross b. So here we have Cartesian product, that is a Cartesian product b will be the minimum of mu a of x and mu b of x. This is the formula for Cartesian product of fuzzy sets. So a dash cross b dash, that is a dash and b dash are fuzzy sets. So Cartesian product of fuzzy sets will be minimum of mu a of x and mu b of x. So we have to find the minimum value. So how will find the minimum value? So given here, they have given a dash as three values, 0.2, 0.5 and 1. So write these values here. Write x1, x2, x3, here y1, y2. Okay, so here we have to find out the values. So it is given as 0.2 in for x1, 0.3 for y1. So here if we write a table like this, and here if we have to find out the minimum of these two values. So minimum of this x1 value and y1 value. So what will be the minimum of this x1 value and y1 value? So among 0.2 and 0.3. See, I'll write it here. A dash is 0.2 comma x1, 0.5 comma x2, 1 comma x1 by x3. So B dash will be 0.3 y1, 0.9 by y2. So here we have two values, okay, A dash and B dash. Now here we have to find out the minimum of x1 and y1. So what is the minimum of x1 and y1? So what is minimum? It's 0.2 and 0.3, minimum is 0.2. So write the value 0.2 here. Now x1 and y2, x1 and y2. So what is minimum value? 0.2. 0.2 and 0.9, minimum value is 0.2. Now x2 and y1. So x2 and y1, 0.5 and 0.3, minimum value is 0.3. Next 0.5 and 0.9, x2 and y2. So minimum value is 0.5. Then 1 and 0.3. So minimum value will be 0.3. 1 and 0.9, minimum value will be 0.9. So this is the value for the Cartesian product, that is a dash cross b dash. Okay, we'll see the next problem in the next video. Thank you.